In plain polarised light, the grains in this thin section are colourless and have low relief, which means that they don't stand out from the section. It's hard to tell them apart, but some grains have a slightly cloudy or turbid appearance, and a few show faint traces of cleavage. There are also patches of darker, turbid material in the spaces between some of the grains. When the stage is rotated, there is no change in the colour of the grains. On the cross polars, it's easier to see grain boundaries. Note that the grains neither show straight and regular outlines or crystal faces, nor have a banded appearance. The grains are largely sub-rounded to subangular in shape. This means the rock is a sedimentary rock. It's possible to identify the grain size, grain shape and mineral properties. Most of the grains are between 0.5 mm and 2 mm in size and are moderately to poorly sorted, which means that they show a range of different grain sizes. The sub-rounded to subangular grains are touching, so the rock has a grain-supported fabric. There is no preferred orientation of the grains. The grains are largely composed of feldspar and quartz, although there are also a few lithic or rock fragments. Quartz is identified by its grey and white first-order interference colours. It's best identified by its lack of cleavage and twinning. Some of the quartz grains show a wavy extinction when the stage is rotated. Feldspar also shows grey and white first-order interference colours, but it is best identified by its cleavage and twinning. Some grains show simple twinning. This is orthoclase feldspar. Other feldspars show crosshatch twinning. This is an example of microcline feldspar. Feldspars may show multiple or lamellar twinning. This is plagioclase feldspar. Rotation of the stage in one direction results in the sets of lamellae going dark and reaching extinction. Rotation in the other direction results in alternate lamellae reaching their extinction position. This grain is a rock fragment. It is a polycrystalline quartz grain made of interlocking quartz crystals. These grains are usually sourced from metamorphic rock. The material between the grains, the intergranular material, is fine-grained. Although it was turbid or cloudy in plain polarised light, it has low-order interference colours under cross polars. This material is composed of clay minerals. In summary, this rock is a coarse-grained, poorly sorted sandstone that is texturally and mineralogically immature. It is texturally immature because it is poorly sorted and is composed of sub-rounded to subangular grains. It is mineralogically immature because it has a high percentage of feldspar. More than 25% of the grains are feldspar, which means that this sandstone can be called arkose.